Good afternoon, participants. Chandrakant Motekar. Hello, Chandrakant.
Yes, sir.
Say your friends to join the meeting as early as possible.
Yes, sir.
Just wait for 2 minutes. We'll start. Divekar sir is there. Sonone sir is there. Okay. Good afternoon, all participants. So today we'll start. Today is the last day for this faculty development program on industrial IoT and industrial 4.0. So last two sessions are very much informative for all our participants, but today's is also important because today the two participants are discussing about that the application of industrial IoT. So I welcome the resource persons, Sunil Sonole sir and Divekar sir. Please give the brief about the applications of the Industrial 4.0 to all the participants. So I welcome again and please move forward to this FDP program. Thank you, thank you, thank you very much.
Okay. Jadoo sir, I am audible?
Yes, yes, sir. Yes, sir.
Okay. Firstly, we complete the remaining two topic in a previous session, sir.
Okay, no problem, sir. So in previous session, there are two topics are remaining. Divekar sir will continue that two topics. So Divekar sir, please continue this the remaining topic. So I hand over to you and Sunil sir.
My screen is visible?
Yes, sir.
Okay. In a last session, we start with the some key technology which is used in industry 4.0. In that, we firstly studied the first one, cyber physical system. Second one is augmented reality and virtual reality, how to use in an industry. And third topic is artificial intelligence with the help of the machine learning and deep learning in the industry 4.0. Now in this lecture or in these sessions, we cover the two topics. The first one is big data and second one is a cloud computing or fog computing in the industry 4.0. The first one is big data. The firstly, what is meant by the data? Data is raw facts and figures. Means it is a combinations of the all these things. Your audio, video, images. All files are the data in the form of computer. And in the industry, use that data to improve their productivity, scalability, and marketing purpose. Then what is meant by the big data? The simple one definitions of the big data is terms used to describe the large amount of data in the network, digitized sensor lane, which is the collected from the different types of the sensors, and the information driven in the world. This is a simple one definition of the big data. Actually, The big data is categorized into the two types: structured data and unstructured data. The structured data means the data that can be easily organized and it is stored in a relational database. These data are stored in a relational database is called as a structured data. And these data, structure data, are managed by the SQL database. SQL means a structure query language database. But structure data is only 20% of the data in the today's world. The second one type is unstructured data. The unstructured data, that data which is the does not possess any predefined model, means it is unstructured. It don't have any format for that data. That's why the unstructured data is not handled by the traditional RDBMS or DBMS. And these types of the data is a hug amount of the data in the real world, means it is 80% data are available with the form of the unstructured data. These are the two types of the data. Now the next one is characteristics of the big data. In that there are two structures are there. There are mainly three V's which is included in a big data: the volume of data, velocity of data, variety of data. And some structures will be used the value, visualization, variability, and veracity of data, which is the characteristics of the big data. Now we are go to the one by one. The first one is a value. Value means it is a hug amount of data, means large amount of data, means large amount of quantity data are included in a big data. Means the source of that data is continuously increases. For example, the more than 32 terabytes of feature will be created each night from the large symptomic survey telescope, LSST. In a one night, it can be created the 32 TB pictures a data. It is a large amount of data. The second one example is that in every minute, the 70 hours video is uploaded on a YouTube. It is also the large volume of that data. The second one characteristics is a velocity. Velocity is a speed of generation of data. Means high speed of accumulations of data. And that's why in a velocity, the data processing time is decreasing day by day, because speed of data is increases. And it can be provide the real-time services also. So the older processing technology cannot helps to the handle that velocity of the data. For example, 140 million tweets per day on an average of, according to the survey of 2011. Also, In a stock exchange, New York Stock Exchange is measure the 1 TB of exchange data during the every exchange session. Means the value or volume of data is also increases. Second one, simultaneously speed of generations means velocity is also increases of the dead data. The next one is a variety means category of the data means different format of the data from the various sources. There are n number of sources are simultaneously enter the data in that database, and there is no restrictions over the input of the data formats. There is no restriction for the data format. Some files in a PDF, some files in a video, some files in a images, text, GPS data, image, audio, video files is also there. And these are data is mostly the unstructured data or no structure to available for that data. And this characteristics is a variety of data is also increased in a simultaneously. The next one characteristics is a variability. Variability means the different types of the category of the data, different form of the data. Means data can be changed, it's continuously changing its format or is changing its value. Such a data appears as a indesirable mass without the structure of that data. For example, in a language processing, hashtag, and the multimedia sensors events are the used at different types of the variability of the that data. The next one is a diversity of the data. The diversity indicates the in the data unstructured and noise data are there. Means some useful data with the addition of the noise. Means it is inconsistent and uncertain data is there. And in a diversity of the data, it is important to the in a program which involves the amounted decision making is required. It is also important for the feeding the data into the unsupervised machine learning algorithms which is the used to that sort that data. Means diversity deals about the data understandability, not just the data quality. The next one is visualizations. Means data in a which visual form is used in a picture in the form of graphical representations or graphical format. How to visualize that data, it can be covered in a visualization characteristics. Means visualizations provide the power to decision making to see the visual result in a visualizations, and it is very helpful to the identify the new patterns in a big data. And then last one characteristics is value. It means that the extract the useful data within all the data or collected data. Means it can be, it means the extracting the useful business information from the scattered data. Means it can be provide the quality investigations empower with the information decision in the value characteristics. And these are the some characteristics of the big data. And these next one is a different sources of the data in a industry 4.0 or industry. In that, first one is a enterprise data, for example, is a online trading, data analysis, production and inventory data, sales and other financial data are included in enterprise data. Some data is created by the IoT devices, which those are the sensors are created that data, and this data is industrial data, healthcare data, and agricultural data. Means these are data are collected from the sensors or IoT devices. The next one is a biomedical data. It includes the data generated from the gain sequencing, means history of all the diseases and a medical history of that person. It is again diseases data. Data from the medical cleaning. This under the data for the biomedicals. And some others data are also included in big data. First one is a computational biology, astronomy, and nuclear research create the some types of the large amount of data in that. And for that data, we require the analysis. And that analysis is called as a data analytics. The next concept is a data analytics. Because we collect the large amount of data with the different form of data. And without analysis or analytic, we cannot convert that data into the useful informations. And that process is called as a data analytics. The simple definitions of the data analytics is the process of inspiring, cleaning, transforming, and modeling of data to discover the useful information driven conclusion and the support decision making. This is a simple one life cycle of the or life phases of the data analysis. In that first one is a business issue understanding. Means this structure is basically used for the business purpose. Before that, we explain the how to data analysis work. In that there is simple one process is that there are some types of the sensors are there. There are some sensors are there. These sensors are or collect the data we call as a sensing. And sensor can connected to the different connecting devices or networking devices, which is called as a connection phase. And in a connection phase, we use the different types of the connectors or networking devices with the help of protocols. And these connecting devices are transmit that data to the computing. The computing means there are different types of the computing technologies are used in that. And in this computing technology, we are using the analytics. Use the analytics. And this, after the analytics, the data are transmitted to the control stage. Transmitted to the control stage. And in control stage, we already studied it can be used some system which is called as a cyber physical system is used in a control stage. And after completion of the control stage, it can be go again the sensing devices, means those are the actuators, means output devices will be display that information. This is simple one process of data analytics in the industry. Now the life cycle, as the purpose of the industry or smart factory, firstly, the first step is check the business issue or understand the business issue which is the required in industry. It defines the business objectives, gather the required informations, and that inform in a business, determine the appropriate and analyze a methodology which is the use in a first stage, clarify the scope of works, and identify the durability of that works in a business issue or first steps of the analysis. After the completion of the business issue understanding, it go to the second one step, which is called as a data understanding concept or data understanding steps. And in these steps, if the collected initiate the data or collected data are identify requirements of that data, determine data is availability or is not available, explore that data and characteristics of that data, and transmit to the next one phase, which is the data preparations. In a data preparation phase, gather the data in multiple sources, cleanness of that data, format of that data, blend of data, and provide some sampling of that data, which is created in a third steps. The next one steps is the exploratory and analysis of that modeling. It can be used to develop the different types of the methodology and determines the importance and variables of that data. Build some models or use the different types of the models to analyze that data and access also that models. And then it can be transmitted to the next one steps, which is called as a validation steps. After the creations of the different types of the models, it can be validate that models or evaluate that result with the review process is there and transmit that data to the next steps. And then last one is it is a visualization and presentations of the result data, or we call as that data is called as information data. And that informations or the data is determined to the best method and present in the base of analysis and in the front of different types of the audience and companies. And this is a simple one life cycle or phases of the data analysis. In a industry IoT or industrial IoT, there is a simple one stage is there. In first one is there are industrial assets, machines are there. There are different types of the machines are connected with the sensors, and all these machines are interconnected with each others. And collect the informations and transmit into the connectivity. This connectivity use some networking devices or controlling devices or edge devices which can be controlled that information and transmit to the next level, which is the industrial IoT analysis process. And then collected data are stored in a cloud, and that data are used to provide some informations or created some information which is called as a new insight and intelligence in between them. After the completion of the analytic process, this information or result of data are transmitted to the information system, The information system is some example is a ERP system and all this business ERP systems are there. Sometimes it is used for the business processing, and sometimes it can be used for the different types of the peoples. And these information we call as informations are again transmitted to the industry to optimize the decision making and intelligence operations. Means suppose we create the different types of the data, collect that data by using the different types of the networking devices, transmitted that data to the analytics. Analytics will be converted using the different types of the models, and it can be find some informations on presenting information and provide some result on the data, and it can be transmitted that again into the industry, and that information used for the increasing the productivity scalability of the industry. That is a simple one use of the data analytics. The next one is there are three types of the data analytics are there. First one is descriptive analytics. Second one is a prescriptive analysis. And third one is a predictive analysis. In first one is a descriptive analysis. The data deals with the what happened in a past. It can be calculated the what happened in a past. It is related to the past. The second one is a predictive. It deals with the actually what will be the happen in a futures. It can be checked that what happened in a futures. And third one is a prescriptive analysis. It decide that how can we make it happen? How can we make it happen? It can be decided in a prescriptive analysis. Okay, and this is a simple one example for the aircraft. You know that at the time of the aircraft fleet, the flight data recorder is on, and it can be store or collect the near about 10 TB of raw data in every flight. And these data are transmitted to the predictive analysis. In a predictive analysis, it can be used that data, aircraft and engineering models, operational data. Means this data is used for that one. Predictive analysis means it how to find in a futures, and it can be transmitted to the prescriptive analysis. And a prescriptive analysis, how can that make it happens? Means it can be detect the fault causes, condition trends, which condition is at that time, and how to work on that conditions. It can be also used for the fuel efficiency, and it can be transmit that data and that analytic informations to the into the business inside in a near about 2 GB. Means 10 TB data can be converted into the 2 GB only data. This is simple one example of the data analytics. The next one is a cloud. How to need of cloud in a industrial IoT or industry 4.0. The major concern to handle the hug amount of data we call as the big data is there. The nature of data is unorganized data is there. Machine to machine use or sensors data collected is there. From the heterogeneous big number of devices are in a industry, and varying the data quality. These are the needs of the cloud to store the data in a cloud instead of the server. What is mean by the cloud computing? The cloud computing is a technology that enables us to create, configure, and customize the application through the internet connections. It includes the a development of platform, hard drive, software, and database. It is a simple one definition of the cloud computing. The cloud computing is suitable for the scientific and business adaptability. It fulfills the need of what, when, and where the data solutions are there. What data is your, when to store the data, and where to store that data. The next one is cloud computing is a secure storage and secure access as compared to the local storage or data centers. It supports the coherent explainability and coordinate the business model. And it also supports the mobile devices. Actually, cloud computing, this is infrastructure of the cloud computing. There are different types of the sources, home sources, laboratory, industry, transportations, industry. It is categorized into the infrastructure mode. It includes the computational infrastructure is required. We call as the data centers are required to store that data. We are using the different types of the platform for the database, different types of server, services, runtime services are required. We call as a middleware is required. Some applications is required in a cloud computing to analytics, monitoring, predict, and decision making in that. And it is also categorized into the three types of the clouds are there: public cloud, private cloud, and hybrid cloud. The public cloud is a setup for the use of the any person or any industry which is the publicly accessed by the anyone. For example, Google Computer Engines, Amazon Web Service, Microsoft Azure, these are the public clouds are there. Private is a cloud setup for the single organizations which cannot be shared by the another publicly, that is called as a private cloud. And hybrid cloud, it is a two or more unique cloud setup with the combinations of the private and public. Means it designed to advantages of the both private and public. Means it can be flexible. Sometimes it can be used as a private, sometimes it can be used as a public. These are the three types of the also in a cloud computing. This is simple one architecture of the cloud computing is there. There are different types of the sensors or collect the information and transmit that information in a gateway devices. These are the networking devices. We call as a gateway device. And these gateway device are transmit that data to the cloud. And cloud will be stored that data, and some data acquisition and analytics or data analytics used to then convert that data into the informations or some results are formed. Industry applications. There are different types of the applications are used to using that data. And these are the simple architecture of cloud computing. Where to use the cloud computing in IoT, industrial IoT? It can be used in an industry, big data storage, heavy weightage and algorithms and data analytics are required in industry, prediction of failures before the accuracy, real-time device monitoring, data privacy and security. For that purpose, we require the cloud in a IoT. And these are the some platforms which provide the cloud services. In that, by the industry, it can be provided the JE, Predix, Siemens, Midship, Honeywell, some software developed firms are there: C3 IoT, Uptake, Meshifi. These are the some software firms create that cloud. And the cloud is not sufficient for the industry 4.0, because industry 4.0 requires some aims to achieve the great production optimization decision is required, efficient and availability is required. It also requires the deeper insight in the analysis prediction. It establishes the connections world of the machine, system, products and environment. Means it can be connected with the around the world. The collision of data in each sector performing analysis or analytics to exploit that wealth of that base data. Means the requirement of the industry 4.0 is increases, and cloud will be not handle that requirement. The solution is for the decentralized and distributed approach along with the cloud. Means cloud will be used to decentralize or distributed approach for that data. It also used to the handling the time sensitive data. It required also the use the immediate action and quick response for that data. It can be reduce the delay, and for that purpose it can be used the fog computing. And then fog computing is a decentralized computing model that can be bring with the computational and the data storage. It is closer to the edge and the network. Means it is a added layer between the edge or smart devices or smart gateways and the cloud layer. But it is cannot be replaced the cloud. It is work between the edge and cloud. It is used to the identify the useful data, thus reduce the amount of the raw data, because as the scrutiny is done at the fog levels and send the required data to the only cloud. And that's why it can be increase the scalability and reduce the traffic on a cloud. Means it can be used the intelligence devices deployed at the edge level. It also use the intelligence computing devices known as fog nodes. Some changes had made at the that edge levels. It also required the intelligence and providing the services like the filtering, aggregations and translations in the fog levels, and distributed that one level, centralized one on other levels. Means all the raw data, instead of going to the cloud, it can be filtering, aggregate and translated data are transmitted to the only cloud. Why fog computing is required in IoT? These are the some reasons. It consists of releasing the data from the sensors and machines. Data may be in a critical as well as a time sensitive. Needs to immediate action to the quick response is there. Reduce the delay. And there are some major challenges to handle the data by using the different types of the protocol, different types of the data syntax and different types of the data sources. And this is simple one fog computing architecture is there. You see that these are the some physical level or physical layers is called as a. It includes the actuator, cyber physical system, smart devices, smart machinery, smart cars. Are these are the. Which is the example is a smart industry, smart grid system, healthcare data, smart home data. These data are transmitted to the edge layers. Edge layers is using the some advanced devices, or which is also called as gateway levels or connecting networking devices are used in a edge layer, and transmitted the data to the fog layers. The fog layers are There are different types of the fog nodes are we call as a fog nodes are there. A number of fog nodes are in between the cloud and the edge. And these after the after the informations scrutinize the data are only information or some selected data are transmitted to the cloud. This is simple architecture of the fog computing in a industrial IoT. Means filtering of data, aggregations of data are only stored in a cloud layer. That's why it can be increase the productivity and scalability of that industry. Now these are the some platforms which is the provided by the fog computing, foghorns, Nebulon technology, Crosser and SOMS. And then some applications in a industry 4.0 and IoT is in a data mining sector, smart grid and power, transmutations, and oil and gas industry. And these applications are explained by the my colleagues Sononisa. Okay.
Thank you, Divekar sir.
Thank you,
Please take,
Sonal sir. Thank you,
uh,
Divekar sir, for your valuable inputs from today's applications of Industry 4.0. So I welcome again the Sunil Sonal sir. Please move forward for this FDP program. Welcome, Sonal sir. Okay.
Thank you, sir. Please check my voice. Am I audible?
Yes, sir. You are audible.
Okay, just take my screen. Sir, is it visible?
Visible, sir. Visible.
Okay, thank you, sir. Okay, good afternoon, everyone. I am S.S. Sonone, working as a lecturer in AISMS Polytechnic. And today I am going to conduct the last session of this workshop. Today I will end this session and workshop with this uh, topic of Introduction to Industry 4.0 and Industrial Internet of Things. So already we have studied this basic concept of this workshop earlier on a first day before yesterday. So in today's last session, I will cover these points like applications and case studies for Industry 4.0. So I will not take your more time. I will just conclude all these terms and things within 15 to 20 minutes. So let me give some time. So we will discuss application and case studies. So basically Industry 4.0 or IoT, industrial IoT is applicable in various fields, various numerous fields. If you see on my screen, you will see that it is IoT applicable in oil industry, chemical industry, pharmaceutical industry, factories and assembly line industries, food industries, healthcare industries, plant security and safety industries, facility management industries. UAV means unmanned aerial vehicles, where the driverless car or drones or driverless rockets are uh, in manufacturing phase. In this kind of industries, IoT or industrial IoT could be a beneficial. Not only these sectors, but other sectors, IoT also 4.0 specifically is very useful. So I would like to briefly expose to the different applications of industrial IoT in chemical industry. Mostly out of these sectors, I will consider today only this oil industry, chemical industry. and pharmaceutical industry. So I will focus only on these three industries. So before that, I would like to uh, explain these three kind of industries. As I told earlier, as as well as all these different application domains or core technology, the core technological ideas remain the same. Means there is a industry. In industry, the machinery available in industry is same. In this industry, the other plants of that industry with their machinery are connected in a similar manner. So, what are the differences in IoT 4.0? In IoT 3.0, as we are using this kind of industries nowadays, we are just adding some different devices. Means your machinery will become smart, your connection between this machinery will become smart, connection between plant to plant will become a smart, connection between a person with industry will become a smart, the product of that machinery and the process used to make that product is is smart, as well as the transportation medium which will carry this product, that will also smart, and the interaction of that manufacturer with the vendor and the interaction of vendor with the customer, all these become smart with the help of specialized devices like sensors, actuators, transistors, and all these machineries are connected to internet through IoT. So that internet makes machines smart by their smart connectivity. So we are using the same infrastructure that we are using in 3.0, but we are making that infrastructure in a smarter. We are making that infrastructure smarter. So as I told you earlier, as well as in all of these different application domains, they we are not changing. They cannot change. They are basically the ones that we have discussed in the previous module, means a day before yesterday. So the only thing that changes is basically the type of sensor, the sensor that we would use, the specific requirement that a particular industry has, and certain industry specific requirements mostly are application level and the network level or device level. So more or less the concept remains similar like earlier industries. The concepts are similar with previous industries. So in this lecture also consequently I am not going to talk about anything new drastically, but I am going to expose you to the some requirements that are specific to these industries like oil, chemical or pharmaceutical industries, and how these specific sensors and their interconnectivity can help to address the issues that these industries are facing. So we can make these industries smarter. So let us start with these industries. So let us look at these issues in detail of these three industries. But before we do that, I would like to have a recap because this is going to be a last application, and I am going to expose you to this particular section on this application. So I am going to take you through a recap of these issues that there and advantages that can be obtained from IoT implementation in this industry, specifically 3.0 industries. So in other words, in a nutshell, let us talk about specifications or specific characteristics of industrial IoT once again. We have looked in different levels of uh, IoT details earlier, but now I am going to expose you to the summary of different requirements that there are. So we want to industrialize, our industries have been operating in their respective fashions since long ages. Whether we are talking about the oil industry, whether we are talking about the chemical or pharmaceutical industry, or manufacturing industries. These have been going to since ages, uh, long years ago, since decades. These have been carried on using traditional methodologies, but only now we are talking about the use of IoT or IIoT, IIoT solutions. So we are doing that in order to improve certain things by using IIoT. We we want to improve the efficiency. We want to improve the overall cost effectiveness in operations and so on and so forth. In other words, what we want to do is what we want add values. We want to add values to the product. We want to add values to the processes. Uh, Already the processes already running and traditional processes. So we want to add value by integrating all these IoT strategies, IoT solutions to these products and services. So if you see the value addition should come out through this incorporation or integration of IoT solutions. Essentially, what what going to happen? We are going to improve efficiency. We are going to increase the reliability, safety, security, maximize the profit, maximize production, and at the same time, we are going to slash the cost, means reduce the cost of production, the cost of manufacturing, the cost of goods, all this. So improving the productivity, reducing the cost, which is essential, uh, we can say that these benefits of integration of IoT solution in industry sector will become fruitful. So if you see this diagram, now let us come to the specification in terms of oil and gas industry. So before that, let us see the definition of oil and gas industry that was defined by Deloitte Industry. So there are globally, different efforts globally that are going on this particular industry domain, like oil gas industry domain, or lot of efforts are going on this kind of industries in operating. So there are they are talking about having solutions where integration of IoT with their existing processes, machinery, etc. The benefits is something that I have already told you at the outset. But what is going to happen through the integration of oil and gas companies would be able to directly manage their existing assets, their costs, and their machinery, uh, supply chain, or customer relationship that basically will help the business overall. So the productivity of the businesses is going to improve. The customer relationship is going to improve. The asset management is also going to improve. The cost reduction is going to happen, and so on. So overall, this is what is going to happen in oil and gas industry through the integration of uh, IoT solutions. So this quote given by Deloitte that I have taken from the literature of Deloitte. So if you focus on the next diagram, so in this diagram, this is something that you are already familiar with. We have looked at it. Let us relook at different ways. But essentially, I told you earlier, everything remains the same. The only thing that changes is basically a industry domain, a specific requirement. But from the technology point of view, from an IoT deployment point of view, uh, IoT solutions point of view, things are essentially almost same. But still, for completeness or sake of getting a bit of idea about implementation issues in different domains, let us still relook at this entire process of IoT. So ultimately, what we need data. We need data from doing different things. We need data from predicting something that might happen that might happen in future, miss happening in the future event, and miss event that going to occur in the future. So this is what might happen. We need a data that the data that about different parts of the process. We need the data about the health condition. Uh, we need the data about the machine. We need the data about workforce or the employees. So that working and so on. So we need data finally. We need data to predictive analytics. So depending on the analytics, we will like to we will like to specific objectives that we have. We means the specific industry that is implementing the oil and gas industry that is implementing the solution. So we will have some specific analytics objectives. So based on that objectives, different IoT devices are going to be deployed, like sensors, actuators, etc. So are going to be deployed in different locations. After these sensors and actuators, they will they will have a specific objective. So different location in that plant, within the plant, or also different machines that are going to be involved in the process, in the supply chain and so on. So different IoT devices are going to be deployed. Thereafter, these devices would generate lot of data. This data could be even augmented data within certain simulated data as well. So those data and real one plus the simulated ones and could be together used to analyze. They could be used to analyze the priority on an exact transform, and they could be used to load the processes. Processes could be implemented thereafter. So the data thereafter can be moved after this specific processing, basic processing, and processing the data could be moved to the cloud-based platform where the depth of analytics is going to be performed, and these analytic solutions are going to be starting with the analytics objectives that were set at the outset. So finally, uh, based on the results of this analytics, requisite actions are going to be taken. For example, the devices that need future maintenance that would be identified. Also, the devices which would need immediate maintenance, they would be identified, and the segregation of data, the segregation of the machinery, consequently based on different criteria are going to happen. So there is overall the entire life cycle of the IoT deployment till control of machinery. This is overall the life cycle. The overflow or the workflow that is going to be implemented, and this is going to be implemented in the oil and gas industry. And this is what I this is already happening. This is what is already happening. There is existing work initiatives that are focusing on implementation of this kind of solutions in oil and gas industry. So uh, for analytics, we need what? We need huge processing capabilities. We need adequate intelligence in the form of machine learning AI algorithms, which in turn that going to be executed in cloud. So we need all of this. machine learning and all other algorithms with cloud. So we need all of these, and we these are these are the steps in the machine learning and cloud based services that are going to be integrated with the IoT solutions for the oil and gas industry. So this is already something that is happening. Different systems are being deployed these industries globally in order to realize these solutions. So basically, it is start like this that starts with examining the current state of the architecture. Thereafter, the next step, which is going to be identifying the specific data type, finding the assumptions and constraints of data type, identifying the requisite uh, suitable the target machine or the targeted machine learning algorithm that is applicable, identifying the cloud platform, analyzing and evaluating the data, providing a top down review and illustrating the context for eliminating or limitations and solutions, and finally creating a roadmap. So these three phases towards a roadmap. So it is in these phases that we could also implement a certain suitable visualization engine for appropriate monitoring and understanding of the results of analytics. So overall, we want to improve the operations by using IoT 4.0. So different attributes such as predictive maintenance, location intelligence, pipeline monitoring, equipment monitoring, monitoring of these sensors that are integrated to the pipelines through the machines and other machineries. So real-time machines taking part in these industries in different processes, their execution and so on, and the operations, all of these operations, and so on. Other performance, overall performance could be improved with this incorporation of integration of IoT devices. Uh, IoT not only does what I just told you, but IoT is also uh, capable of increasing the customer loyalty, connecting the businesses, connecting different businesses and different other components, smart applications, energy consumption profile, and so on. So all these things could be improved and could be made handy and available to IoT to the customers, so that all these are in different industries. So the benefits of using IoT in oil and gas industry is already quite apparent and quite easy if you apply all these sensors and machineries of IoT 4.0. But essentially, let let us recap and try to summarize what are the different benefits. Benefits include increasing the productive efficiency, production efficiency, saving all costs, saving on the time, improving asset maintenance, enhancing product or production or product productivity, work safety, and supply chain management, and so on. So uh, let us start with chemical industry. Uh, in the chemical industry, likewise, IoT could be used for improving the overall processes, productivity, reducing cost, total cost of product is getting reduced, and so on and so forth. So, in the chemical industry, once again, let us have a look at these different benefits. We have different predictive maintenance. We have condition based monitoring of different machineries that are taking part in these industries to carry out different processes to execute them and so on. Improvement of logistics could also be done. improvement of the quality, improvement of the management of different equipment in these industries, minimizing the supply chain and reduction of energy expenses. These are also benefits that could be achieved through IoT integration in chemical industry. So, in predictive maintenance, such as addressing different issues that are going to happen in real time in the future, now or also in the future. So, seconds later or 2 minutes later, 2 hours later, things that can happen. So, predicting those in advance is what predictive maintenance concerns. So, reducing the equipment breakdown time and downtime is what going to be benefit out of this predictive maintenance. So, what is required is through appropriate predictive maintenance or through integration of IoT devices. So, we are going to have efficient and effective maintenance and improvement of the quality by different IoT analytics, IoT analytics programs, and in turn improving the overall services that are delivered. So, in condition-based monitoring of this industry, in condition-based monitoring is going to be a possible. It is going to be possible to predict the quality of continuous monitoring, water level in this industry, nutrients level, uh, also pesticides that we are using in this industry, uh, and all these monitoring pesticides and their analysis and analysis in real time is going to happen through a integration of IoT solutions. Analytics predicting weather and their impact on farming. So analytics predict the weather impact on farming and adjusting the amount of required material, pricing model or profit margin. These are the some different attributes of condition based on monitoring which are going to be implemented through integration of IoT solutions. So, how to improve the logistic into these industries with the help of IoT 4.0? So, improving logistic, ensuring product location through sensors or RFIDs, radio frequency identifiers, which are in the form of tags. Uh, these are the tracking assets. Uh, so we can prevent a loss in logistics. Detection of uh, or detection of attack or alert notification in warehouse monitoring, which are going to different things that can help to improve total logistic process. How to reduce the energy expenses. Uh, e- Reducing energy expenses, energy usage, regulatory monitoring or regulatory control is required to reduce all these expenses. So, analyzing real-time data, improving the usage pattern or behavioral pattern of users, identifying the inefficiency in energy usage, reduction in inefficiency. So these are the different characteristics, the different things about energy expenses and reduction of energy expenses is of which is of concern or problematic. So how to minimize the supply chain risk whenever a product is transmitted from one industry to another industry or one floor shop to another floor shop. So in minimizing of that supply chain, minimizing supply chain risk is very important. So chemical manufacturers can respond immediately to the required process whenever it is required, as and when it is required based on the specific requirement that might be there. So real-time monitoring is the supply chain of equipment, material being used, raw materials, finished product, or finished good processes like worker environment. So everything is in real time, monitoring in real time of the entire supply chain, and the participants in supply chain, be it can be a human, the workers and the laborers who are working there, and so on. So be it the different machinery, everything is going to be possible to be monitored in everything in the supply chain, which is going to be possible to monitor in real time. So now let us took an case study of pharmaceutical study. Already we have done the study on uh, oil and gas industry and study of factories. Now let us study on pharmaceutical industry. So before I talk about the IoT in pharmaceutical industry, let us see whether we are understand this is in detail enough. So let us try to look at the particular thing. Let us say that we want to implementation of IoT in uh, this pharmaceutical industry. So normally what happens? Normally, so we are essentially talking about what we are saying uh, about different industries. Suppose there are different industries. We have a industry with different machineries into it. Uh, in a domain of machinery with a different plants of that machinery and different machinery in different plants. So these, let us say, the industries that would deploy different sensors. So there is a sensor here. There are several sensors in industry. Different sensors in different parts of these industries. Uh, di- Different sensors in different floors also, and these field equipments are connected with each other. So all of these different sensors are going to be deployed, and these sensors are connected through each other through various protocols or various technologies like Wi-Fi, IEEE 802.16, or Zigbee, and there are several devices and protocols. So all of these different sensors are going to be deployed. So these data are finally going to reach some servers. So this data will ultimately go to this uh, server. So going to reach some servers and it cloud. Suppose this is a cloud server. That cloud server will have some storage. So some storage will have also some processing capability. So some multi processors or some controllers are here. Some storage space is here, and a cloud with some analytic feature. So this processing capability and storage capability and this data would be analyzed and would be made available to, say, to a manager. The manager will do analytics all of this data. So manager at very higher level. I'm mentioning manager at very higher level. So it could be any type of manager, whoever needs access to that data. So this is holistically going to happen. And for chemical and oil industry, these different sensors have different levels, and different levels could be used for a different type of data. So different sensors that could be used to send data in a traditional way. So that data will be uh, common, like your data will be like temperature, your data will be like uh, data of proximity sensor, data will be like any other most kind of sensors. So these are the different kind of sensors, and some of specific chemical sensors could be also used in this plant. So these are the generic one sensors. And finally, ultimately, one of the manager of controlling all these operations. So, and some chemical sensor uh, like electrochemical gas sensor on different types of gas sensor, fluorescent, fluorescent chloride sensor, pH sensors. These are very common sensors in oil industry or chemical industry. So, potentiometers, these are also one of the kind of sensors. So these are the chemical sensors. Likewise, gas sensors could be any of the gas sensors like carbon monoxide, carbon dioxide, or methane sensing sensors. So these are so many kind of sensors at different levels. So these are some different sensors in the chemical domain, in gas domain that I have mentioned. If you recall, when I talk about the sensors in the industry scale, uh, we were talking about smart sensors. So that smart sensor senses the data of this machinery if there is going to happen wrong in terms of this machinery. Uh, and there is a feedback needed. If product is produced by these industries, that product must be feedback by that machine. Means product is produced, that product is going towards the analytics. Analytics will do all these operations and the feedback should be given to this machinery so that that machinery will improve that product. So that smart sensor will work to improve that product. Okay, as well as that smart sensor will sense the line of production, the speed of production, process of production, as well as the smart sensor will inform to the manager if something goes wrong. So these gas sensors are actually also applicable in these different industries like oil and gas industries. So they could be used for oil and gas industry. What also happens in typically from the point of the oil and gas procured or maybe generated typically, you will find that there are different ways of transporting oil and gas. Okay. So the things that there are in the pharmaceutical industries, you have different plants which are making different drugs and so on. These drugs are also used for the drugs and their monitoring of drugs, also monitoring different subjects, different animals which are used in drug manufacturing and so on, also quite often used. So IoT can help in doing these trials for the production process of different drugs and so on, monitoring those in much more efficient manner. For example, production of vaccine, it goes through different steps so that finally goes through certain trials in different sorts of trials. So these pharmaceutical companies, they take these different drugs through different equipment. These drugs are tried out in different phases. They are manufactured in different phases and finally tried out in through different subjects and so on before these drugs are released in the market. So for this entire production process, in this entire production process, the supply chain and sensors IoT solution could be deployed in order to improve the processes, to monitor the quality of the drug, the intermediate steps monitoring the quality of these intermediate steps, and so on. So everything could be done in a much more efficient and precise manner. So IoT sensors could be deployed in production areas that could help in getting huge data from this manufacturing department. In this pharmaceutical industries can help in real time monitoring. This can help in controlling these areas remotely. So we can improve the utilization of this equipment, utilization of machineries, and can help in reducing the production of cost. Also, can it will help to reducing the wastage. So these are the some uses of IoT sensors in pharmaceutical industry. Uh, so IoT application in pharmaceutical industry include examination of drugs, and not just the final drugs, but also intermediate ones that through go through which the processes that are incurred in between the in order to transform these raw materials into final stage. So throughout from the raw materials to the final drug, examining the quality, quantity, also monitoring the different chemical reactions that are required uh, in order to transform one part of the chemical to the another part and so on. So all of this basically in the entire process, IoT solution could deployed or IoT solution could also deployed in order to detect adverse drugs reaction of uh, from person or pharmaceutical uh, persons, also detecting allergies, other complications that might be that meant that might be happening in industry regularly. So all of these drugs reactions and allergies, etc., monitoring those, detecting those, everything could done in pharmaceutical industries. So these are being done with the help of different appropriate sensors. So quality control by real-time monitoring, safe and secure drug delivery deployment of different solutions to have in improved manufacturing or in improved monitoring, improved controlling and distribution. So these are the different other requirements in the pharmaceutical industry. How to improve logistics with the help of IoT 4.0 in pharmaceutical industries. So improving logistics, tracking the movement of pharmaceutical goods. These are the normally general activities that happens in pharmaceutical industries. So improving warehousing, optimizing routing, maintenance of machines and equipment, inspecting or inspection of machines for medicines and vaccines. These are also going to improve with the incorporation of or integration of IoT in the pharmaceutical industry. So finally, before I end, uh, I would like to list these different types of sensors that we are going to use in pharmaceutical industries. So for the pharmaceutical industry, also for the first time of all what happens, let us say that a pharmaceutical industries make certain drugs. So there would be different raw materials. So raw materials are going to be used. These raw materials are going to be taken through certain manufacturing process, and finally, the final products are going to be supplied. So these are going to be delivered through trucks or other vehicles and other logistics. Uh, so these raw materials undergo different types of processing. These raw materials we would like to subject different chemical treatments. These raw materials are going to be subjected through different pressures under certain pressure conditions, temperature conditions, in certain humidity conditions, and so on. So performing different reactions with agents in pharmaceutical company or reagents under certain temperature, humidity, lighting conditions, and so on. So all these things are going to happen. So what sensors are going to be used in general to certain chemical or specific chemical detection, specific chemical sensors and other sensors are temperature sensors, because you need to conduct a certain reaction in medicines or on a drug, or maybe uh, uh, testing a condition under certain temperature settings in certain lighting conditions, light sensor, temperature sensor, pressure sensor in certain pressure conditions. So these reactions have to be happened. So pressure sensors like this, there are different other sensors that would be also used in pharmaceutical industry. So finally, we come to an end of this session. Uh, Let me just write or say name of that sensors which are applicable in pharmaceutical industries, like pH level sensors or alkaline sensors, byproduct sensors, and different sensors that could be used. So finally, we will we come to an end in this lecture. As usual, these are the different references. I would like to encourage you to go through the different reference that I am showing you, different reference sections. These are a lot of videos that could also use to get better understanding of these applications of IoT in this different industry. Even in oil industry, gas industry, pharmaceutical industry, there are a lot of different videos are available on YouTube. So you could try these videos, try it out for different open media, uh, Facebook, YouTube. Lot of different videos are exist on this media. So these are the references. Finally, we come to an end. Uh, so from my side, I have completed all these IoT applications, and in all these 3 days, we learned about different technologies in IoT 4.0 and how to implement IoT 4.0. We started from the basic generic terms about basic IoT 4.0. Then we studied different types of IoT 4.0, how to implement, which devices are should be used in IoT 4.0. Then we seen different technologies required for implementation of IoT 4.0, like cloud technology, AI, ML technology, uh, cyber physical technology, and various technologies. So, at the end of this session or end of this FDP, I have completed all this uh, data from my side. And if anybody have any questions regarding this any topic, you could start your mic and you can ask us if any problem there. Otherwise, we will conclude our session. Yes, anybody wants to ask questions? Otherwise, I will conclude it. Okay. Uh, so that is the end from my side. Uh, Jadhav sir, are you there?
Yes, yes, sir. Yes, sir.
Oh,
Uh,
so you can conclude, sir.
okay, no problem, sir. Uh, the both the research persons from they are explained very much well, and from the starting from the day one to last day, all the faculty members from various colleges are understanding that the industrial 4.0 and industrial IoT. So brief explanations are given both of you, the resource persons. So thank you from KSRIT Polytechnic, Rajaram Bapu Institute of Technology Polytechnic Lohegao. We'll big thank for this the faculty development program. So I hand over to Miss Komal ma'am. Please continue the sessions regarding the thank you message. Okay.
Good afternoon, everyone. Good afternoon, distinguished guest, principal sir, and all present here. It's my honor and privilege to deliver the vote of thanks at the conclusion of this enlightening session on Industry 4.0. This 3 days event has been tremendous success. First and foremost, I extend my heartfelt thanks to our esteemed speakers, Mr. Deveka sir and Mr. Sonone sir, who have generously shared their valuable insights on the transformation that Industry 4.0. I'm also thankful to all participants here in person or virtually. Thank you for being a part of this event. Thank you once again. Thank you so much, sir.
Okay, thank you. The participants will get the certificates at this on this FDP WhatsApp group. So wait for that certificate. We have to prepare that certificate and we have to drop that certificate on that FDP group. So in 1 or 2 days we can drop that certificates. So thank you Divekar sir once again and Sunil Sonavane sir for giving your valuable time for our this faculty development program. Okay. Okay. We will leave now all. Then that.